Hey everybody, we are going to find slope given a couple of tables here. In our work with slope, it's important that we actually look and see what truly the slope is given these various tables. You'll end up finding tables in this unit where it looks like there's probably not a slope. In other words, it's not a linear relationship. However, when you dissect it a little bit deeper, you'll find that it actually truly is, because slope is all about, is there a consistent change in the y values versus the x values? So finding slope given a table. Let's look at these two basic tables that we have here. So right here versus right here. We are going to look at how we are changing in each of the x values and how we are changing in each of the y values and seeing how those compare. So -1 to +1, I have to increase by 2. -2 to -1, we're increasing by 1. And I am going to do this same thing. And notice I can keep starting with the y values. Why am I doing that? Because when we're looking at slope, we're looking at rise over run. And of these two variables, which one of these actually focuses on rise? That's the y values, versus the run, which is the x values. So notice this table is written with x's on the top and y's on the bottom, because x is our input and y is our output, and that makes logical sense for that. But in terms of our slope, when we actually go to look at it in terms of an equation and what we're going to have to deal with, we are going to be putting our y value that we get here, our change, on top, versus our x value will be on the bottom. And that's really going to throw us for a loop. So let's continue. 1 to 3, we're increasing by 2. 3 to 5, increasing by 2. 5 to 7, increasing by 2. Every single time. That's what we want to see. If I look here in my x values, -1 to 0, I'm increasing by 1, increasing by 1, increasing by 1. -1 to 0, 0 to 1, 1 to 2, increasing by 1 every single time. So what I'm seeing is I am seeing a steady pattern here. As I increase by 2, I'm increasing by 1 in my x's. As I increase by 2 in my y's, I'm increasing by 1 in my x's every single time. So I can write for my slope, which is a rise over run, or we could also look at this in terms of vertical change versus horizontal change. Hopefully we can see that. Yep, vertical change versus horizontal change. We are looking at a vertical change of 2 for every horizontal change of 1. So the slope for this table is equal to increase by 2 over an increase by 1, or I can simplify that to 2. All right, now let's look at this next table down here. We are, notice, I'm starting with my y values every single time. I'm always going to start with my y values. So I'm always going to look at rise over run. X values. So my increase or my decrease in y's, -4 to -2, that's an increase by 2. -2 to 0, increase by 2. 0 to 2, increase by 2. 2 to 4, increase by 2 every single time. If I look at my x values, I'm increasing from -6 to -2. I'm increasing by 4. -2 to +2, increase by 4. 2 to 6, increase by, I wrote that as a 2. Increase by 4, increase by 4 every single time. So if I'm looking at this, my slope is rise over run. My rise, I'm increasing by 2 for every time that I increase by 4. I'm increasing by 2 vertically, and I'm increasing by 4 horizontally. So 2 over 4, which I can simplify to 1/2. So this particular table shows me that I'm increasing by 1/2. Now, I'm going to throw us for a loop here. Now, what if our table ended like this? So increase by 8. What if my table ended like this? It looks like the pattern is no longer holding, like the increase by 2, increase by 4 sort of thing. The thing is, it actually is. It's totally holding. So before I was jumping up by 2 every single time, right? And up here, I'm increasing by 4 every single time. Well, what if I just increased by 1? Okay, what if I just increased by 1? What would I want to see as my change in horizontal? If I increased by 2 every single time and then I got 4 as an increase in my x-axis or x values, I would want to see if I increased by just by 1, I would want to see an increase just by 2. So the thing is, I want to see that the ratio holds. I don't necessarily care about the points that are provided here, just that these ratios hold. So 2 compared to 4 is the same ratio as 1 compared to 2. They simplify to equal each other. So I can say 2 to 4 is equal to 1 to 2. So it doesn't matter that I've changed in terms of my pattern. It's not a plus 2, plus 2, plus 2, plus 2 pattern. It's not that. What matters is this 2 to 4, 2 to 4, 2 to 4 is equivalent to 1 to 2. Does that make sense? So 2 to 4 is equal to 1 to 2. So the ratio is the same. You will end up finding some problems that we're going to be doing, and you'll have to identify whether or not the table is showing a linear relationship. And do not jump to conclusions too quickly, because you may see this pattern show up. Okay. All right. Have at tables. Now we have one more video after this. And after I finish that video, you can attempt the must-do problems. Okay. Thanks for watching. Bye.